Hi everyone, myself Dr. E. Sridevi, Professor Biomedical Engineering, and in this video lecture we are going to learn about histogram equalization techniques and histogram manipulation techniques. To understand this session, we will start with one problem. So it is given us construct a histogram equalization for the following 8-bit image segment of size 5 cross 5. Write the inference on image segment before and after equalization with histogram processing and equalization techniques for the given 5 cross 5 matrix. It is given like this. Some pixel values are given. For example, row wise I am reading 200, 200, 200, 180, 240 and 180, 180, 180, 180, 190 and 190, 190, 190, 190, 180 and 190, 200, 220, 220, 240 and finally the column is given as 230, 180, 190, 210 and 230. So it is given, the given image is taken as it is 5 cross 5 image and it is also given as it is only 8-bit image. It is taken and image size is 5 cross 5 and gray levels are 0 to 255 for 8 bits. So first you count the values and write the frequency of occurring that value. So 190 is occurring 6 times and 190 is occurring 7 times, 200 is occurring 4 times, 210 is 1 time, 220 is 2 times, 230 is 2 times, 240 is 2 times. The total pixels values are 255 and occurring is 25. It is given. And probability distributive function we are going to calculate for 180 for 6 times P of R is equal to NK divided by 25. So P of RK equal to NK is 6 divided by and it is given as 25. This value, all the values are calculated. So for given values P of RK is calculated by noting the formulas NK divided by 25 and cumulative distributive function summation that is summation j equal to 0 to k P of j is calculated, that is for 180 it is 2.4. each and every values are taken and finally this value will be 1. So 180 2.4, for the next one is 2.4. So both are added, so that is for example 2.4 and 2.8 will be added, so it will be 5.2. then 5.2 and 0.16 will be added, that is 0.68. Similarly for all the values are added and CDF cumulative distributive function is calculated. Histogram equalization formula is written in such a way that S of k is equal to L minus 1 into cumulative distributive function of RK. The L is given as L is equal to 256, so S of k equal to 256 into cumulative distributive function of R of k. So now considering these tables are cumulative distributive function and that repeating values and it is rounded to that value. So for the given values CDF 24 that is n of k divided by this value is calculated, this value is this one, then that is rounded. For 61.2 is rounded to 61 and 244.8 is calculated as 245. Mapping of old and finding the new gray levels. So original is 180 and equalized value both are considered and tabular column can be written as the original images and round off images both are taken. So it is taken like this. Final equalized matrix will be wherever 180 is wherever this value is there, 200 is there, it should be finally converted to 173. 180 is there, it will be 61. So we are having the new equalized value for the original value. So replacing this one, 180 by 61, 190 by 133, 200 by 173, 210 by 184, 220 by 204, 230 by 224 and 245 by 240 by 245. We are having the matrix like this, that is 173, 173, 173, 61, 245, 61, 61, 61, 61, 133, 133, 133, 133, 133, 61, 133, 173, 204, 204, 245, 244, 61, 133, 84, 184, 224. So this is called as histogram. So before histogram equalization, the pixel values are concentrated between 180 to 240. Now histogram is narrow and clustered, so low contrast image details will not are not well enhanced. So histogram interpretation consists of gray levels which are spread over the wide range of 61 to 245. So histogram becomes more uniform and image contrast is significantly improved, better visibility and detail. So histogram is a graphical representation of gray levels on x-axis, number of pixels of frequencies on the y-axis. In this equalization, the basis of histogram equalization is a contrast enhancement technique which is used in digital image processing, and it is for an grayscale image. One histogram is like this. So taking this one and writing same problem, same thing is repeated. For example, repeating values are concentrators, and it for a p of nk and x cumulative distributive functions are calculated, and finally before and after equalization contrast values are calculated, and final value is replaced by the original value. Original values are replaced by the uh, histogram equalized enhanced values. So advantage of this process is simple and effective, enhances contrast automatically, no need for prior image information. So limitations are may amplify noise which is not suitable for all images, can over enhance some regions. So where it is applicable is medical image processing, satellite and aerial images, industrial inspection, and document image enhancement. So hope you all understand this one.